All right, everybody, we've gone back a bit to 4.4. We're going to look at the second fundamental theorem of calculus. So we've been looking at integrals where a and b here, definite integrals, are constants. You know that if you integrate that, little f of x, you get capital F of b minus capital F of a, which is the antiderivative. But we can also have integrals that are defined as functions. For the most common example, or famous, I guess, would be the natural log function, which is our next chapter. Chapter 5 is all about logs. So get excited for that. It's defined as the integral from 1 to x of the graph 1 over t dt. In other words, if we are looking at you are looking at what the value of this area is. So if you say natural log of 2, that's a 2, put a 2 in there, and that becomes a 2. So it's the area of under the graph of 1 over t from 1 to 2. That's what the natural log of 2 represents. So what this means is, though, if you can take derivatives, obviously, and so you're doing derivatives of integrals. So we're going to do one that we know how to do. Let's move this up. So if I say f of x is equal to the integral from 0 to x of, let's do cosine. It's the same one that's in the book. Well, the integral of the cosine function is a sine function. Sine of t evaluated from 0 to x, which would give me sine of x minus sine of 0. And you know sine of 0 is 0, so we just get sine of x. That's what f of x is. So what if I say, well, what is f sine of x? Well, looking at this, you would say derivative of sine is cosine. So what that can mean when you look at what f of x is defined as this function is f of x is the derivative with respect to x of the integral from 0 to x cosine of t dt. And this essentially is the second fundamental theorem of calculus. If you look at it, the shortcut is this derivative and this integral are reverse processes, so they essentially cancel each other out. And this variable is up into there, and that's how you get your answer. So the second fundamental theorem of calculus states fundamental theorem is this. It says the derivative of the integral from, that should be a constant, to a variable function of f of t dt is equal to f of x. The function must be continuous. On the interval. Because if you don't have a continuous function, then integrating it gets a little tricky, and then deriving it. All right, that's the second fundamental theorem. So we're just going to do a couple of examples here. So if I say f of x is equal to, well, I don't know, integral from 0 to x of, I'll do secant of t dt, and I say find f prime of x. Well, okay, that's easy. The derivative is going to cancel the integral, and the variable gets put in. So you get secant of x. That's it. Done in one simple step. Now, what if It's not just x up there. So we'll do one that we already did. We'll do the cosine one. So if I define f of x to be the integral from, well, I'm going to use the one exactly. There's 0 up here. So we'll do 0. It can be any number, it doesn't matter. From 0 to 3x squared minus x plus t dt. Okay. So pretend that's not there. Sorry. Pretend the 3x squared isn't there. Up here, when we did the derivative of f of x, right, we just got cosine of x. Okay? So that means f prime would be cos of whatever x is, right? But that's what we have. So we're actually doing f prime of 3x squared minus x. So in this blob here, you have to have 3x squared minus x. But chain rule says you do the derivative of the outside function, which is the whole thing, times the derivative of the inside function, which is that. So you have to multiply by 6x minus 1. Okay? So let's do another one. We will do, whoops. Let's do, oh, I don't know. That's a good one to do. Let's do one from the book, actually. Where's this? C. If f of x is equal to the integral from 4 to cosine of x of x squared, oh sorry, that'll be t of t squared dt. So you just go and I say what's f prime? Well, the first step is the cos x goes in for t. So t squared of t times the derivative of cosine. What's the derivative of cosine? Negative sign, and that should not be t. I'm sorry, people. That should be an x. Times the derivative of cosine, which is negative sign. So to clean that up, it would be negative sine of x cos squared of x. That is the second fundamental theorem. Okay? The questions from the book, which are basically just like the ones I just showed you here, just doing some practice. You'll see when we get into the log function, it's important that you understand. Well, that's how you get the proof of the log derivative, or the natural log. So page 285, number 73 to 77, just do the odd ones. You can do even if you want. And page 290, 81 to 91. Actually, they're both on page 290. Sorry. Page 290. Okay. I'm sorry, people. This is horrendous. I'm looking at the wrong page number. Page 290, numbers 75 to 91. Odd. That's what I would like you to do. All right. Good luck, and let me know if you have any questions. Thanks.